All right, so this does come from chapter 4, but what we're kind of getting into, I want to kind of give you a bigger, broad idea of what's going on, okay? So we learned chapter 4 was how to solve quadratic equations. Everything was x squared. How many answers did you always have? You had 2. This chapter, chapter 5, we get into x cubed, x to the 4th, x to the 5th, x to the 6th. You get a lot more answers, okay? Now, like quadratic formula, it was like, yeah, it works on everything. It works on every quadratic x squared equations. It doesn't work on an x cubed. It doesn't work on an x to the 4th. So what we're going to look at graphing today just so you can like see how all this kind of works together with the answers to problems versus their graphs and things like that. And then next chapter, we kind of mold into the graphing calculator becomes your best friend. And it helps you solve when it has like 5, 6, 7 answers, like it helps you find a lot of them so that you can then turn it back into quadratic so you can then use the methods I've taught you and go from there. Okay, so you're going to have a lot more answers in chapter 5. Okay, so but today we're going to look at graphing by hand so that we can then kind of transfer that knowledge into graphing calculator. If I just went straight to graphing calculator, you wouldn't truly appreciate where things come from and understand what the numbers mean. Okay, so the standard form of a quadratic function, we should know this. What's standard form? So ax squared, there you go, plus bx equals 0. Good. All right, so that is our standard form. Typically when you're graphing, they don't say equals 0. What do they usually say if you're graphing? Y. They're usually, remember y equals mx plus b? So technically you could write this as y equals. So if you see y equals, we're graphing. That's what that means. Okay? All right, so a blank is the graph of a quadratic function. Do you know what a quadratic graph looks like? Even if you don't know the name, do you know what it looks like? Diane, yeah, what's it look like? That is like the 4 quadrants of a graph. Those are quadrants. You were close. They had the qua in it. Yeah. Yeah, it's the U. It's funny he said U and he did this. He's not wrong, though, but it's just kind of funny. Oh, say that again. Parabola. There it is. A parabola. Please don't pronounce that parabola. I know it's like how you spell it, parabola, but it's parabola. All right, so a parabola is the graph, and you're right, that is like the U shape, right? The U shape, or he made that symbol when he said that. Yeah, they're both parabolas, okay? They're both x squared graphs. The path of any object flying through the air can be described as, it does, yes, parabolic. He did say bolic, but yeah, I knew what you meant. Parabolic. I always laugh at this, like I put Angry Birds on here because that's what's happening in Angry Birds, right? You shoot your bird. It's a very stretched out one, but it's still going to make that same path when it comes down. It's a very stretched out parabola. They do. This is going to hit the ground, but it still has that same shape to it, okay? I always say, though, like any object, so like you pick up your brother or sister and you chuck them through the air. You're like, hey, Mom, look, I made a parabola. Don't do that. Don't get in trouble. All right, but that's the same idea, like anything that throws through the air. Take a baseball, play catch with somebody. You're making a parabola every single time that ball goes back and forth. I said don't throw your children. Don't. Well, you got your siblings. Yeah. Mm-hmm. Yep, always, which is kind of cool. Yeah, I remember I was in college, we had to do like this big project, learning about like how to teach and stuff, and we did one on Angry Birds. Like we literally played the game, screenshotted like as it was flying through the air, and like had to write the equation of the bird flying through the air. Which, unfortunately, we don't have time, otherwise we would do that, but it is kind of cool. Like, yeah, you can write the equation of it flying through the air. All right, so let's start real basic here. Put the equation in standard form and name A, B, and C. So, easy enough. So the first one should be y equals, what should be first? Then? Good. So what's your A value? Your B? And your C? Beautiful. Yeah, see, we got this. When have we done this already?
Every day.
Right. What formula do we have that uses A, B, and C? Quadratic formula. Yeah, we should know how to do this. All right, what about number 2? It should be y equals. Good. What's your A? Your B? And your C. Good. What about number 3? What the heck's that F parenthesis X? What's that? Yeah. The Y and that's pronounced F of X. That's how you read that, F of X. That's function notation. It's just a name. Like his name is Frank. It comes in handy a lot if you're like dealing with a lot of story problems and you're writing equations. And I always use the example like I'm making pancakes. How much, how many eggs do I need for pancakes? So if I'm writing an equation about pancakes, I might name it P of X for pancakes. Eggs, E of X, just so I know. It's kind of just a way to name your equations. So don't get overwhelmed by that funky little notation. All right, what is it written okay? Do I need to rewrite anything? I mean, if you really wanted, you could write y equals 2/3 x squared, which is fine. But y and f of x, they're used interchangeably. So if you see f of x, you can write y. What's your a value? B? 0. And your c? Also 0. Good. All right, so we know standard form, we know a, b, and c. Moving on. All right, the point where the parabola changes direction is called the what? I don't disagree, but it's not the word we use in math.
Axis? No.
Starts with a V. Somebody I think said it over there. Vertex. That is the vertex. Right? So you throw in baby brother, right? He's up here, and then eventually he's got to come down, right? So where it changes from going up to going down, that's your vertex. Don't throw. You know, it's funny. I'm the youngest, too. I don't even have younger siblings. I'm the baby. Although my brother did tie me to a chair when I was little, and he said it was because he was teaching me how to tie knots. Not really sure that was his goal there. Yeah, I have older brothers, so. All right, it opens which direction if A is positive? So back here, my A value, this one's positive and that one's positive. Which way is the graph going to go? Will it be a U shape or an upside down U? If A is positive. We'll talk about that. It's upside down. Ooh. There we go. Oops, sorry, vertex. It opens up, meaning, oh, I said that backwards to you, didn't I? It opens up, meaning it looks, oh, I'm writing in red. It opens that way. It opens up if A is positive and has a blank point or value. Is the vertex going to be the maximum point or the minimum point? It's a minimum. It's the lowest point on that graph. There you go. So if it's positive, the A value, if the beginning of that equation is positive, it's going to be pointing up, which makes sense. But the vertex then is the minimum. It's the lowest point on that graph. It opens blank if A is negative. It opens down if A is negative and has a blank point. Is the vertex the minimum or the maximum? It's the maximum. All right, so if you look down here, I went ahead and put these on here. So if I have just a positive x squared, it's going to be opening up. If it's a negative x squared, it opens down. So like if you put the arrows on the end, they actually point negative, and these are going to point towards the positives. All right. Decide whether the parabola will open up or down, and whether it will have a maximum or a minimum point. So just like what we just talked about, can you tell just by looking at the equation? So number 4, it will open up. Why? Yeah, your A value is positive, so it's going to open up, and it will have a minimum value, right? Right there. It's going to have a minimum for its vertex. All right, number 5, will that open up or down? That will also open up. Now notice that's not in the right order. But the A value is the number with x squared. It is positive, so it will open up, and the vertex will be a minimum. Number 6, that will open down, and that then, good, that is the maximum point. Guess I could have circled, right? I was too happy to write it up there. Easy enough? Okay, there should be certain things, and next week when we actually start section 5.1, we'll talk all about end behavior of graphs, and like just by looking at an equation, I should have a rough idea of what it looks like without even graphing anything. All right, so now we're going to actually get into like graphing them by hand. Okay, so first thing we need to do is find the vertex. So to do that, we need to first start by finding the x-coordinate of a vertex. Remember a vertex, when you're graphing, we're looking for a point, right? You guys remember this? We always have x, comma, y when you graph points. It's probably been a little while since you've actually plotted points, right? Yeah. You guys ever do those things where you plot the points and then like connect them and it makes a picture? I always like those. Those are fun. When I used to teach Algebra 1 in Finley, I used to make them create their own pictures and plot their own points. That was fun. Yeah. Yeah. I taught that in Algebra 1. I'm not teaching Algebra 1. No, it was really cool the things people came up with. All right. Anyway, so first we need to do is find the x-coordinate of the vertex. So we're going to find this part right here. So to do that, we use negative b over 2a. You're going to want to memorize that. Negative b over 2a. So if here's my problem, we're going to find the x-coordinate first. We do the opposite of b, which would give me negative 8 over 2 times a. 2. All right, so that makes negative 8 over 4, which is negative 2. There we go. So you just found the x part of your vertex. You just do negative b over 2a and just simplify it and see what you get. That's the x part. No. Well, depends how you type it in. Your calculator, if you use the graphing ones, yes, because it will show you top of fraction, bottom of fraction. If you use a scientific calculator, it's going to do order of operations on you, which is not what you want. You could just type that straight in. Yep. Using the fraction button. Yes. But I mean, did you see how I did this though? I just cleaned up the bottom and then I divided. That's all I did. All right, so then to find the y-coordinate, right, the y-coordinate, which is this part, you just take the x that you just found and you just plug it back into the equation. So 2 times x squared, so negative 2 squared, plus 8 times negative 2 plus 5. Could you type all of that straight in your calculator? Yeah, you sure can, and I probably would. Because otherwise it makes my head hurt to try to do it in my head. Is that negative 3? All right, so that gives you negative 3. That means my vertex is negative 2, negative 3. That is your vertex. Because as we get into graphing these, if you can't find the vertex, you can't actually graph these very easily. You can, but it would take you a lot longer. She's at her guidance counselor right now, so she'll be back. All right, questions on what I did right there? I heard this is easy, so that makes me feel good. All right, so let's practice them. Let's just find the vertex. So before we actually graph, let's just make sure we know how to find a vertex. So first thing we need to do is use the negative b over 2a. Does negative b over 2a sound eerily familiar? Where have we seen that before? A quadratic formula. Yeah, it starts out negative b, and that's all over 2a, so it's similar. All right, so negative b is going to be negative 4 over 2 times my a value, which is 2. So that's negative 4 over 4, which is negative 1. So there's the x part. And then to find the y, just plug it back in. So 2 times negative 1 squared plus 4 times negative 1 minus 7. Very good. All right, what about number 8? What's negative b? Good, it's going to be a positive 6 over 2 times what's a? 1. So that's 6 over 2, which is 3. Will that number always come out nice and pretty? No. Can it be negative? Yes. Obviously, number 7 was negative. Could it be a fraction? Yeah, it can be. All right, so don't panic if you get a fraction there. All right, and then to find the y part, plug it back in. So we have 3 squared minus 6 times 3 plus 5. Is that negative 4? Check me on my mental math. I'm very tired today. All right, so let me give you guys a couple minutes. Why don't you guys try 9 and 10 on your own? Okay? All right, so number 9, what is your b value? So negative 0 is just 0 over 2 times a, which gives you 0 over 6, and 0 divided by anything is just 0. All right, so then to find the rest, 3 times 0 squared minus 4 is just negative 4. So just be aware, anytime you're missing a variable, it's a 0. Don't just leave it blank. You need to put a 0 in there. All right, and then number 10 I know is throwing you guys because it doesn't work out nice and pretty. So negative b is going to be 3 over 2 times my a, negative 1. Some of you may have lost the negative sign there. So we get 3 over negative 2. All right. Well, that's not pretty. Did you lose a negative on yours? Let's see, I thought you did. Your a value is negative 1. Yes, remember a is in front of x squared. So then when you plug it in, you're going to have 1 minus 3 times a negative 3 over 2 minus negative 3 over 2 squared. Remember, anytime you're plugging a number in, make sure it's in parentheses. This is just like quadratic formula. If you didn't put it in parentheses before you squared it, remember, I gave you the wrong answer, so make sure you put things in parentheses. No, the calculator can do it for you. Remember, I'm lazy, right? So I'm not going to if I don't have to. All right. So 1 minus 3 times negative 3 over 2. Wait, say that again?
Y works out to be a variable. Like it's just 4.
On this one?
Yeah.
I got 13/4. Anybody else type that in? You got 13/4? Same thing. Did you remember the negative one?
Power.
Oh, yep, that'd be it. All right. Now, real quick, though, I want to kind of talk. Typically, in this class, we leave things improper. But if you are graphing and you're plotting a point, do you know where negative 3/2 is? My guess is probably not. What is 3 divided by negative 2? negative 1.5. Do you know where negative 1.5 is? Yeah. What about 13/4? So it's, yeah, 3 and a fourth. So 3.25. Do you know where that's located? Yeah. So if you're actually graphing and plotting points and you get improper fractions, you're going to want to switch those so you know where they're at. Right? You know how to go back 1.5 and then go up 3 1/4. That makes sense. But to go back 3/2 and 13/4, like you don't know where that exactly is located. Okay? Questions on finding vertex? Oh yeah. Oh yeah, yeah. You can put decimal. You can put fractions too. Calculator will do any of them.
Something there, right? I think.
There was a negative in front of this. Because there's a negative in front of your x squared. Yeah, that's why. All right, so let's go ahead and look at a graph. See, what do you guys remember back from your pre-algebra, Algebra 1 days? I kind of set up a little table for you to help push you in the right direction. Chris? That is typically what students are taught, and that is what sticks in kids' heads. You're right, it does. That was what I was hoping you would say, actually. When you're graphing, you can put any number you want in for x. Anything at all. I could put 1,000,000 in there if I want. But I got to graph this. And my graph is only negative 10 to 10. So I'm trying to keep it on my graph, right? If I put in 1,000,000, it's not on my graph anywhere. All right, so what we do, we could put anything we want in for x. So let's go ahead and do this. Let's see what we get. So all you're doing is plugging it in. So what's negative 2 squared? It's 4. What's negative 1 squared? What's 0 squared? 1 squared. 2 squared. Look at that. We have points we can now plot, right? All right, so negative 2, 4. Do you remember how to plot a point? The first number goes left and right on the x-axis. The second number goes up and down. Just making sure we're good. So I'm going to go back 2 and then up 4. I have back 1 and up 1. 0, 0. It's right at the origin. 1, 1. And 2, 4. What does that look like? It looks like a U, which is a parabola. Good. Now, I want you to notice a couple things with how I drew my parabola. One, that's probably one of the best parabolas I've ever drawn and actually hit every dot. So everyone take note because it probably won't happen again. But where did my lines go? Did they stop right at the dots? They didn't. I went ahead and went past them. Okay? Don't just go dot, 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 done. Okay? Make sure you kind of extend beyond them. Say it again. Please still go beyond them. Reason being is sometimes it's hard if all your dots are really close together to see kind of what's going on. So we want to kind of just extend those so we can see it, and don't forget your arrows. Arrows means it keeps going forever and ever and ever. Now, what is the vertex of that graph? It says 0, 0. Did you know that without doing any math on it? How did you know that? It's the minimum point. It's where it changed, right? Okay, so that's your vertex. Now, the way this is going to work is we graph from here on out. I don't like to put in 5 points because I'm lazy. I'm going to do less, okay? I want to know, first and foremost, I'm going to find my vertex, because usually just by looking at an equation, I don't know where that is. I'm going to find my vertex, because that is kind of like my, you ever do those things in art class when you were a kid where you take paint and put on one side of the paper, fold it in half and the paint's still wet, and you open it back up? You ever do those? If you've never done those, you really should. They're kind of fun. But what happens, that fold line, when you folded it, that's like your, it's called a line of symmetry. That's where it's the same on this side versus this side. Is that true with parabolas? Yeah, wherever the vertex is, that's kind of like your fold line. It's exactly the same on this side as it is on that side. So me being the lazy mathematician, if I know where the vertex is, I know where it's going to fold that paper in half, right? If I find 2 of the points on this side, do I really have to find the ones on that side? No, I don't. Because if I look, if this is like my fold line right on my x or my y-axis. This point is one space away from it, so I would move one space on the other side. This one's 2 spots away from it. I go 2 spots on the other side. I can do half the math. Yeah. I wouldn't have to do all of them. So really, I will find the vertex, and then I'll do like a table for 2 points. And that's it. Cool, right? Now, I know I can go any number I want for x, but my tables are limited. I want to try to keep them on there. They don't always fit, because sometimes the way the problems are written, but I want to try to keep them on. So once I find what my vertex is, I'm going to pick the vertex. That's the negative b over 2a that we just practiced. Once you find the vertex, I'm going to find the very next point over and the very next point over from that. So I'm trying to keep them close to the vertex to hope they stay on the paper. And I'll show you what I mean. All right, so we just did that. We're good. All right, so step 1, find the vertex. So let's start with that. We're graphing 2x squared minus 8x plus 6. So to find the vertex, that's your negative b over 2a that we just practiced. What's negative b? It's positive 8 over 2 times, what's your a? So that becomes 8 over 4, which is 2. How do I find the other part of the vertex? Just plug it in. So 2 times 2 squared minus 8 times 2 plus 6. What do we get? Negative 2? Do you guys confirm? I didn't even check that. Are we blindly trusting Dylan? Are we okay? I think they'd follow you off a cliff, Dylan. All right, so my vertex is at 2, negative 2. So let's go ahead and plot that. So we have 2, negative 2. So it's down here. Now, again, I like to be lazy, but for me it helps. And it may or may not help you. I like to kind of draw a dotted line, or you could draw a solid line if you want, kind of showing me this is my fold line, meaning it's going to be the same on this side of the line as it is on this side of the line. Some students try to always take it over the y-axis, and that's not your fold line in your paint, right? It's going to be wherever that vertex is. So now I have to make a table. Since my x value is a 2, the numbers I put in for x, what's the very next number after 2? And then 4. Those are the 2 closest points to my vertex. So for me personally, whatever the x value is, I just go 2 to the right. And that's what I'm going to plug in. So I'm plugging in just like I did before. So 2 times 3 squared minus 8 times 3 plus 6. If you're good with your calculator, you can go right back into the equation you just typed in the vertex one and just change those numbers to 3s. So if you're on your calculator, let's go ahead. Let's type in the one from the vertex, okay? If you didn't do that already, go ahead and type it in. So 2, make sure you put the parentheses. It helps you really recognize what's going on. All right, so once you type this all in, you got negative 2, right? So if you're on the graphing calculator, you just want to arrow up to highlight the equation and hit enter, and it'll put it down there again that you can now kind of arrow back into it. So I'll just arrow back over, and anywhere I had a 2 in parentheses, I can change it to a 3. Dylan, you may want to try yours again there. You should get 0. And do the same thing with a 4. Oh, go back into the 4. So everywhere I had put a 3, change it to a 4. And you should get 6. But see how you can kind of use the calculator to your advantage there, right? Just kind of arrow back into it and change the number out. Whoa. Go back up to what you have. That is a negative sign as opposed to a minus sign right there. So that'll change that drastically. All right, so if I go ahead and plot those points then, I'm going to plot the point 3, 0. So 3, 0 is just sitting right on the x-axis. Can you tell how I reflect that? See how it's 1 spot away? I go 1 spot on the other side. Now I have those 2 points. I'm going to plot 4, 6. And that's 2 spots away from the line of symmetry. I'm going to go 2 spots on the other side. Not bad. I actually touched every dot. How are we feeling? Doing okay? Questions before I move on to look at the next one? All right, so negative 4x squared plus 8x plus 2. So first thing is always find your vertex. So that's the negative b over 2a. So negative b is negative 8 over 2 times my a is negative 4. That gives me negative 8 over negative 8, which is 1. And then to find the y part, just plug that back in. And again, if you're typing it in the calculator this time, when you have to plug other stuff in later, it makes it a lot easier. Good, you do get 6. So my vertex is at 1, 6. So over 1, up 6. Okay. I like to draw that fold line in so I can actually see it on there. So then when I make a table, what numbers would you want to put in for x? Good. If your x value is at 1, I'm going to plug in 2 and 3. I always just kind of count the next two numbers. So again, if you typed it in your calculator, you can just kind of arrow back into it, change all your 1s in parentheses to 2s. And what do you get when you plug a 2 in? You get 2. Same thing again, and change them to 3s. And we get negative 10. All right, and then we just need to plot those and reflect them. So 2, 2. Again, that's 1 spot away, so I'm going to go 1 on the other side of that line. And then 3, negative 10. That was 2 places away. I'm going to go 2 places on the other side. So how hard is it to graph a parabola by hand? That's not that bad. Could your calculator do it for you, like, really fast? Yeah, I can. Tomorrow's focus is graphing calculator. So, did you mess up somewhere? You forgot to square it. Yeah, there should be a square right there. Other questions? Ben? Yes. By looking at the equation, I can give you a rough sketch. And that is what we'll work on Monday. If you want exact, this is exact. But yeah, I mean, I knew before I graphed it, this was negative. I knew it was going to point down. I mean, I knew that going in. Also, you can tell by your C value is where it crosses the y-axis. It crossed it too.
I remember it did that.
Yeah. Yeah, the C value crosses y-axis. Do you have a question? Yes. Yeah. Similar. But that formula makes straight lines, whereas these have a curve to them. But yeah, very similar. All right. Are you okay if I skip some of this and kind of jump to the next part? Are we okay with graphing? If not, I'll do a couple more. Are we okay? I mean, we're still going to graph. I just want to kind of look at the next part of this. So how is the graph of a quadratic function related to the solutions of that equation? Right, last chapter, the whole focus was solving quadratic equations. Right? We found the answers. How does that relate to the graph? Does anybody know before I even get into it? Like if I gave that to you and I asked you to solve it, I'm betting you could. Let's do it real quick. If I asked you to solve this, what method would you use to solve? Say it again. Somebody said. You'd factor, right? How would this factor? Plus 4 and minus 2. So what would you tell me the answers were? You'd say x equals -4 and 2. Okay. Keep that in mind. Now let's go ahead and graph it. Let's see if we can figure out how they're connected to each other. Okay? All right, so if I ask you to graph, find the vertex first. So negative b, be -2 over 2 times a. My a is 1. So -2 over 2, which is -1. All right, and then to find the other part of the vertex, plug it back in. So -1 squared, make sure you put those in parentheses, plus 2 times -1 minus 8. All right, we get -9. All right, so just by finding the vertex, is there any relationship between my vertex and my answer so far? No, there's no relationship there. Okay, so -1, -9. That's my vertex. All right, and then we make our table. All right, my x value was at -1. What are you going to plug in for x? 0 and 1. It's always just the next ones after that. Okay, so let's go ahead and put back in a 0. And what do we get? -8. All right, so 0 and -8. And reflect it. All right, if I plug in a 1, what do you get when you plug in a 1? -5? Yes? I heard a -6 back there. Okay, so I'll plot that and reflect it. Now, humor me. Let's go one more. Plug in a 2. And what did you get? 0. Okay, so if I put 2, 0, that's 3 spots away. So we have 3 on the other. Can anyone find the relationship between the graph and the answers? It's staring you in the face right now. Corey? Corey? The left and the right of what? Where does it cross the x-axis? -4 and 2. Where a graph crosses the x-axis are the solutions to the graph. You're solving for x. So where does it cross the x-axis? Those are your answers for x. Yeah. So at some point you've seen this connection before? Awesome. But yeah, it's kind of cool, right? Like where it crosses is what your answers are. So that discovery right there will help us as we move further and further into chapter 5, where I have to find like 6 answers. If I can graph it first, in my calculator of course, and I can see where it crosses the x-axis, you might find some of your answers just by looking at the graph, which is kind of cool. It saves you a lot of time. All right, so let's try this one. Y equals x squared minus 5. Now, real quick, if I asked you to solve this, what method would you use? Square root method, right? So you'd have x squared minus 5 equals 0. Add 5. And then square root. So what would you tell me x equals? plus or minus the square root of 5. Okay. So let's go ahead and graph this and see what the graph looks like. All right, let's find the vertex. So negative b, what's my b value? 0. Divided by 2 times 1. So 0 divided by 2 is 0. All right, so we plug that back in, and we get negative 5. So my vertex is at 0, negative 5. So it is right on the y-axis. All right, so if I'm making my table, what values for x are you going to plug in? Good, that's a 0, so I'm going to go 1, 2. All right, if I plug in a 1, what do we get? Negative 4. And if I plug in a 2, what's 2 squared? Minus 5. It's negative 1. Go ahead and plug in a 3. We'll go one more number just so we can see this. If you plug in a 3, what do you get? 4. All right, so let's go ahead and plot those. So 1, negative 4, and reflect. 2, negative 1, and reflect. And then 3, 4, and reflect that one. My marker turned black halfway through there. Now, we just talked about where it crosses the x-axis is what the answers are. Where did that cross? Roughly. It's 2 point something, right? So 2 point something. And this one is at negative 2 point something. Somebody type in for me the square root of 5. 2.2 blah, 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 blah. There it is. And wasn't it plus or minus? And there's the minus 2.2 blah, 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 blah. Okay? So they're still there. Radicals are numbers. People kind of forget that a radical is a number, right? You take the square root of it. It's not always pretty, but it is a value. Okay? So we can kind of see that. It's never pretty. You're right. Radicals are never pretty unless they're perfect squares, in which case you wouldn't leave the radical under there. Correct. All right. So solutions, x-intercepts, zeros, roots, those are all words you will hear me say, and they all mean the same thing. All right, so the solutions to the quadratic equation are the points where the graph crosses the x-axis, what we just saw. These solutions, they have different names. They are called the x-intercepts. Somebody threw that word out earlier. They are known as the zeros, because what's the y value right there? It's 0. Or the roots of the equation. I'll be honest with you, the book I used to teach out of, when I taught in Finley, it always called them the roots. That textbook liked that word. The textbook that we currently use, not that you guys ever see it, but that textbook refers to them as zeros all the time. So that means the same thing, they're just different words that you can use for it. Okay, so if I ask you to find the zeros, you just find the answers. If I ask you to find the roots, just solve it. That's all I'm asking you to do. Okay? All right. So let's do another one. What do I do first? Good. I'm going to find my vertex. So negative b over 2a. What's negative b? 8 over 2 times my a, which is 4. So that makes 8 over 8, which is 1. How do I find the other part? Plug it in. Okay, and what do we get when we plug it in? Good, negative 9. All right, so that is my vertex. 1, negative 9. All right, what do you want to plug in for x? Good. I go 2 and 3. Again, my x here was 1, so I'm going to go 2, 3. What do you get when you plug in a 2? I'll let you guys do the work, and I'll just see if you all get the same answer. Good. Bless you. Bless you. All right, and then plug in a 3. 7? Did you guys get 7? Am I faster than you guys typing that in your calculator? Mental math has its place. It actually is faster. And then 3, 7. And reflect it. Oh, my graph got really kind of messed up. I told you that first one I drew was like the best one you're going to ever see me make. All right. And then there's directions down here. Set the function equal to 0 and solve. So it's kind of like what we were just doing. Just kind of reiterate this, connection between them. So what method would you use to solve this? Quadratic formula? Okay. Is there another option you could use? Does it factor? Honestly, at this point, like if you're to a point where like I have to solve it and you're like, I don't know if that factors or not, I may just go straight to the quadratic formula. But I heard quadratic formula first. We can go with that. So negative b is 8 plus or minus square root b squared minus 4 times a times c all over 2 times a. All right, what do we get underneath that radical? I got 144. Would this have factored? Yeah, it would have. Your discriminant's a perfect square. That's okay. What's the square root of 144? It's 12. Can I divide all three numbers? I can divide them all by 4. So I get 2 plus or minus 3 over 4. What's 2 plus 3? 5 over 4. Okay. And then what's 2 minus 3? Negative 1 over 4. What's 5 and 5 over 4? What is that? Because I don't know where that's at, right? That's 1 1/4, so it's 1.25 or 1 1/4. So if I look at 1 and if I could actually draw a better line. I hope yours was better than mine. Oh my gosh, mine's terrible. That's terrible. All right. How are we feeling with this whole process, though? Does it make sense? Pretty easy. Again, remember the process here is find your vertex, plug in 2 other points. If you mirror them, we're good to go. We can graph. And how do we know if we graphed it right or not? Solve it. Do your answers actually show up if you could draw a straight line on a graph like this? I cannot. Yeah, they do.